In this lesson video, we are going to be looking at how to solve word problems. First of all, we're going to have a talk through some different problem solving strategies that you may have heard of. We're then going to demonstrate how to solve some Year 3-4 mixed word problems, a Year 4 word problem, 2 Year 5 word problems, and then 2 Year 6 word problems. These word problems have been taken from the 2019 SATs papers. There are many different strategies out there for helping children to solve word problems. You may have heard of some of these. Let's go through some common ones. We have TEAR or TEAR. T stands for think about the problem and ponder. Explore and get to the root of the problem. Act by selecting a strategy. And then reassess and scrutinise and evaluate the efficiency of the method. There's quack. First look at the question, read it carefully. Then we need to understand by underlining or circling key elements. Approximate. So think about the size of your answers. That's giving it a bit of a rough guess. C is calculate. So actually going to carry out the calculation. And then K is for to know if the answer is sensible or not. So thinking about your answer and thinking whether that would make sense or not. Next we have rucksack. So the first part is to read the question and underline the important bits. The U is understand. Think about what you need to do and write the number sentences you will need. C is then to choose how you're going to work it out. What math skills are you going to use? Then S is to actually solve the problem. To write your answer is A, and then to check your answer is C. Finally, we have RICE. Read and record the problem. So you might want to write the problem out again. Illustrate your thinking with pictures, with models, number lines, with whatever's going to help you. C stands for to compute, calculate and check. So once you've understood your problem after demonstrating it or illustrating it with pictures, you're actually going to calculate it and check it. And then E is to explain your thinking. Can you explain how you approach the problem and how you solve the problem? In this problem from the 2019 SATs paper, this is actually a problem which tests both Year 3 and Year 4 learning objectives. It's a combination of Year 3 and Year 4. Now this question was actually made up of 2 parts, and I have taken the second part of it, which is relevant to the Year 3 and 4 curriculum. So in our question we have information that is relevant and that isn't relevant. Amina is shopping. She says, I would like to buy 1/4 of a kilogram of cheese. Now 1/4 you can see is in bold, so that may be important. Now in actual fact, that was important for the first part of this question, but for the bit that we're going to answer, it's not. So that's why it's important to read the question through. The cheese cost £1.35 and Amina pays with a £2 coin. How much change should Amina get? Now, of all of our strategies, reading the problem is always first and then underlining any important bits. So let's look at the actual question. How much change should Amina get? So change means what does she receive back after she's paid for the cheese? So we need to know how much the cheese cost, and we need to know how much money she gave. So we've got our important bits of information, we've underlined them. We're making sure that we're answering the question of how much change. So we would now need to do our working out. So we've read the problem, we've understood it, we've highlighted any bits of important information, and now I need to decide what maths I'm going to do. So I know that Amina paid with a £2 coin, and that the cheese cost £1.35, I need to find the difference. So I would do a subtract Now I could do my subtract on a number line. There's my £2 and there's my £1.35, and I could find out what the difference is. Or I could do a written method where I do £2 take away £1.35. Now I need to think about how I would set that out. Now when I'm setting out my £2, I could write a pound symbol at the top, that's my pounds, take away £1.35. So these could be my pennies. So what I would need to do is to also fill in my blank spots. £2 has £2 and no pennies. So now I could begin to calculate. Now I'm going to start by calculating using the number line. So here I'm going to round up to £1.40 by adding 5p. And I'm now going to add 10p to get to £1.50. And now I'm going to add 50p to get to £2. So I've rounded up in chunks. You may have been able to just jump up to £2 straight from your £1.35, but if you can't, you can do smaller jumps. I'd now need to add up my 3 jumps. So I'd need to add up my 5p, my 10p and my 50p. I'm going to start by writing the biggest number at the top. 0, 0 and 5 is 5, 5 and 1 is 6, so that's 65p. So let's check using our other method. I can't do 0 take away 5. Can't do 0 take away 5, so I need to go to my neighbour. There's nothing here that I can borrow, so I'm going to go to my neighbour again. I'm going to borrow 1 from here, but I need to exchange that here. Now that I have an extra 1 here, I can borrow 1. That becomes a 9, and my 1 will go here. I can now do this. 10 take away 5 is 5, and 9 take away 3 is 6. My decimal point still goes here because these are my pennies. And now £1 take away £1 is 0. I need to put that in. So I have £0 and 65p. So I could write my pound sign and put 0.65, or I could write in 65p. Do not write in 0.65, that would be wrong. It needs to either have a pound sign at the beginning or just the 65p. Let's move on to the next question. This next question from the 2019 SATS paper also has a mixture of Year 3 and Year 4 learning objectives. Let's first read the question. The picture shows the masses of 8 kittens. So the word masses means weight. So each kitten has a weight labelled underneath it. What is the difference in mass between the heaviest kitten and the lightest kitten? So the word difference has been put in bold. That means we need to really take note of that word. Difference usually means to subtract. We want the difference between the heaviest kitten and the lightest kitten. Now I'm going to rub out these highlights. Let's look for the heaviest kitten and the lightest kitten first. So if we go along from 305 to 375, this is so far the heaviest. 310, this is still the heaviest. 255, this is still the heaviest. So I'm just going to just highlight that. So far this is the heaviest. 275, that's still the heaviest. 410, okay, so that's now heavier. So I'm going to highlight that. 360, that's still heavier. 345. So we found our heaviest cat. Our heaviest cat is 410 kilograms. Let's look for our lightest kitten. So 345, 360, 275. So far 275 is our lightest. 255, so that's lighter. 310, 375, 305. We have found our lightest and our heaviest kitten. So we need to find the difference. Again, using a number line is a good way to find the difference. We have our lightest amount at the beginning and our heaviest amount at the end. And we can simply find the difference by jumping up in between. So I might want to go to 260. I've added 5. Then from 260, I'm going to jump to 300 by adding 40. Then from 300, I'm going to go to 400 by adding 100. And from 400 to 410, I've just got to add 10. Now, if I add up my jumps, I'm going to be adding up 100, 40, 10 and 5. 0, 0, 0 and 5 is 5. 0, 4 and 1 is 5. And 1 is 5. So my answer is 155 grams. Let's have a look at a more standard written method. So finding the difference is the same as subtracting. So if I take my heaviest weight at the top and I take away my lightest weight, let's see what we get. Now I can't do 0 take away 5, so I need to borrow and then exchange. If I take 1 away, that's now a 0, and I'm going to pop my 1 here. I've now got 10 take away 5, which is 5. Now again, I can't do 0 take away 5, I need to borrow. That's going to become a 3, and I put my 1 there. 10 take away 5 is 5, and 3 take away 2 is 1. You can see I have exactly the same answer. My answer is 155 grams. Here is a question from 2019's Past Facts Papers, which is directly linked to the Year 4 National Curriculum. Let's read the question first. John buys 1 toy car and 1 pack of stickers. So we have our toy car with our amount and we have our pack of stickers with our amount. He pays with a £10 note. How much change does John get? So we look at our question. How much change does John get? Change means the money left over. It means you've paid too much money and you're going to get some back. So the first thing we need to do is to figure out how much he's paid. So this will be important information. And then we need to figure out how much he gets back and what he paid with. So he paid with a £10 note. So we have 2 steps in this problem. Our first step is to figure out how much our car and pack of stickers cost. So to do that, I would add my £1.49 and my £1.64. So 9 and 4 is 13, 4 and 6 and 1 is 11, and 1 plus 1 plus 1 is 3. So £3.13, and what I might do here is put a bit of information here, £3.13. That's what the two items together cost. Now the next part of our problem tells us that he paid with a £10 note. So we know he's paid too much. So earlier on, we set out a calculation using money. There's my £10. I'm going to put £10 and I'm going to put my pennies in because I've got £3.13. And if I only wrote £10 like that, it would be very complicated. So I must put in my pennies as well. And remember that I'm subtracting, so I'd put my subtraction sign in, my minus sign. So you could also do this with a number line, but I'm going to use the standard written method. I can't do 0 take away 3, so I need to borrow. Nothing to borrow here, nothing to borrow here, so I have to borrow from here. That's now left as a 0, and I exchange it there. Now I can borrow. That becomes a 9, and I can pop my 1 here. Now I can borrow. Take 1 away, that becomes a 9, and I can put my 1 here. So I'm going to keep going to my neighbour until I can bring 1 back. So I've now got 10 take away 3, which is 7. Then I've got 9 take away 1, which is 8. My decimal point must stay in the same place. I've got 9 take away 3, which is 6, and 0 take away nothing, which is 0. Now I don't need my 0 there. My answer is £6.87. The number sentence that we did, if I used brackets, is £1.49 is 10 take away, and in brackets I'm taking away £1.49 plus £1.64. That's what the number problem looks like if I wrote it as a number sentence. John started with £10 and he subtracted the car plus the pack of stickers. That's what he paid, and what was left is our answer of £6.87. Here's another example of a past SAT question from 2019 that is linked to the Year 4 National Curriculum. This question is related to statistics. We have a pictogram. This pictogram shows the number of satellites above the Earth in 2016. Now we have our axes, we have our, we've got a label here saying that it's the year 2016, and this says number of satellites. And then this bit is our important bit because it tells us that a circle is equal to 1,000 satellites. Now our question is important. How many satellites were above the Earth in 2016? We are simply reading our pictogram. Now I know that every circle is worth 1,000, so I can label my circle. It's a good idea when you have word problems to label anything you can. Label things, draw pictures, just write on the diagrams. So at the moment, I've got that circle's worth 1,000, that circle's worth 1,000. Now what about this? This is only part of a circle. Now, is it half of a circle? Well, no, it's not, because half of a circle would look like that. But it is half of the half. And what is half of a half? Well, half of a half is a quarter. So I'm just going to quickly label here a quarter to remind myself that I've got a quarter of a circle. And now I need to figure out what a quarter of 100 is. A quarter of 1,000 is, sorry. Now to find a quarter, I divide by 4, or I can halve and halve again. So there's my 1,000. Half of 1,000 is 500, and I want to half my 500. Now 5 is an odd number, so if you aren't sure how to halve 500, you can actually split it into a 400 and a 100, because half of 400 is 200 and half of 100 is 50, and I add them together to find half of 500, which is 250, and 250 is a quarter of 1,000, so I could label my quarter circle here. Now I have labelled all of my circles and segments, I can add them up. So I've got 1,000, 2,000, 2,250. So my answer is 2,250. Here is an example of a question which is linked to the Year 5 National Curriculum. It is very similar to some of the questions we've had in that are linked to Year 3 and 4, but the content is slightly more complex and the numbers we're working with are slightly more complex. But the act of reading the question is still the same. So we start with our items. We've got potatoes that are £1.50 a kilo and carrots that are £1.80 a kilo. We've got that Jack buys 1.5 kilograms of potatoes and half a kilogram of carrots. And our question is, how much change does he get from £5? Again, the word change is in bold. It's reminding us that it will be money we receive back, and that when we paid our £5, £5 was too much. So we first want to figure out how much he paid for his potatoes and how much he paid for his carrots. Now we've got the price per kilo, but Jack doesn't just buy 1 kilo, he buys 1.5 kilos. So I need to multiply £1.50 by 1.5, or I could write it out, my 1.5, I could partition them. Here's my 1 kilo and here's my half a kilo. Now my 1 kilo, I've got the price here, is £1.50. If I know what 1 kilo is, how will I know what half a kilo is? I simply need to halve my 1. So that means I also, I'm going to write here divide by 2, that means I also need to halve my £1.50. Now you may be able to do it mentally. If you can't, I'm going to write £1.50 in a bus stop. My decimal point is here, so I'm going to put a decimal point here as well. And I'm going to divide it by 2. 2 does not go into 1. My 1 is carried over. 2 into 15 goes 7 times. 2 times 7 is 14, which means there's a remainder of 1. And 2 into 10 goes 5. So this is £0.75. So half a kilo is 75p and 1 kilo is £1.50. What I need to do now is to add these amounts. So I'm actually going to add it exactly where it is. 0 and 5 is 5. 5 and 7 is 12. Carry the 1 and don't forget the decimal point. And 1 and 0 and my carried 1 is 2. That tells me that my potatoes are £2.25. So I'm going to jot that in. Remember, you can label anywhere you need to on word problems. If you get a question in a test or in class, do as much labelling as you need to. Next, half a kilogram of carrots. Now, if I know that 1 kilogram is equal to £1.80, how will I know what half a kilogram is? Exactly like we did before, this is divided by 2, so this must be divided by 2. So again, I'm going to use my bus stop, £1.80, put my decimal point above. 2 into 1 doesn't go, so I carry it. 2 into 18 goes 9 times, and 2 into 0 goes no times, so I put a 0 there. So it's 90p. Now, very important, this is different to the last question. I don't want 1.5 kilograms like I did with the potatoes. I only want half, so I don't need to add both up together. I only want this. I only want my 90p. So I'm going to write that these are 90p. Now I've got a bit more information about how much each item cost, I can go on to the next step. How much change does he get from £5? Well, I still need to know how much the whole of Jack's shopping costs. So the next thing I need to do is to add my potatoes and my carrots. So I'm going to set it out. £2.25 and 90p. This is where I need to be careful. This is £2.25. For my 90p, make sure you don't put 90p there, because that's actually £90. 90p is £0 and 90 pennies. And we need to add 5 plus 0 is 5, 2 plus 9 is 11, decimal point, 2 plus 1 is 3. So I now have the amount for my potatoes and carrots, so I could simply write next to here £3.15. And my final stage of my problem, you can see we've had to do a few stages. We've had to calculate the potatoes cost, calculate the carrots cost, find out the cost of both of them together, and now we need to take that away from £5. So I can write my £5 in, and I'm going to subtract £3, 3 goes under the 5, and 15p. Now I don't want to leave my 5 blank at the top, so I can put a decimal point and 2 zeros. We need to do some borrowing and exchanging here, because 0, I can't take 5 away from it. I've got nothing at my neighbour. I need to go along one more. That becomes a 4 and that becomes a 10. Now I can borrow from it. That becomes a 9, that becomes a 1. 1 take away 5 is 5. 9 take away 1 is 8. And 4 take away 3 is 1. Not forgetting my decimal point. My answer is that the change is £1.85. Question 15 is linked to the Year 5 National Curriculum. Let's read the question. Amina asked 60 children to choose their favourite flavour of jelly, and these were her results. You can see we have a table where we have a list of flavours, and we have the number of children who chose each flavour. At the bottom we have a total. Now the question is, what percentage of the 60 children chose orange? What percentage of the 60 children chose orange? So we need to know the children that chose orange first of all. And then we need to know the percentage of the 60 children, so the total is important. So 15 out of 60 children chose orange. We know this because it says that there were 15 children who chose orange in our graph. And we know the total is 60, so we know altogether 60 children took place. Now, to change a fraction to a percentage, we need to find an equivalent fraction where the fraction is 100. Now, it's not very easy to change 60 straight to 100 because 60 is not a factor of 100. 100 is not a multiple of 60. So we need to find another way. So we might want to scale down first. So if I look at my 15, I want to think about what factors it has. Now it has the factor 3 and it also has the factor 5. So we could divide it by 3 or divide it by 5. So let's take our divide by 3 first. Now 15 divided by 3 is 5. And 60 divided by 3 is 20. So 15 60ths is the same as 5 20ths. Now let's do it by 5. 15 divided by 5 is 3. And 60 divided by 5 is 12. So I found 2 other equivalent fractions. Are any of those better at going to 100? Is it going to be easier to change one of these two to a fraction over 100? Now, if I look at 3 12s, 12 is not a factor of 100. 100 is not a multiple of 12. But this 20 is a factor of 100. I know that there's 5 20p's in a pound. So there are 5 20s in 100. So I've got to times by 5, which means I'm going to do the same to the top, times by 5, and 5 by 5 is 25. Once I know what a fraction is out of 100, I know what percentage it is, because 100 as a fraction is the same as my percent symbol. So 25 over 100 is simply 25%. So my answer is that the 15 out of 60 children that chose orange is the same as 25% of the children chose orange. Let's take a look now at a question that is linked to the Year 6 national curriculum. A theme park sells tickets online. Each ticket costs £24. I'm going to highlight that. Each ticket costs £24. There is a £3 charge for buying tickets. So there's a £3 charge. Which of these shows how to calculate the total cost in pounds? Which of these shows how to calculate the total cost in pounds? So we're looking at a bit of algebra here. So if each ticket cost £24, what we need to think about is we're writing a statement that someone could use to calculate how much their tickets would cost, and it doesn't matter how many tickets they cost, they can all use the same rule. So we've got number of tickets can be anything. So for example, if 10 people called up to buy some tickets, each ticket would cost £24. So I'm just going to give myself an imaginary number of tickets. I'm going to say 10 people called up. Now, if each ticket cost £24, what would I need to do? Well, I would need to multiply. If each ticket cost 24, then 10 tickets is going to be 10 times 24. So I'm going to write n times 24 underneath, n to stand for number of tickets. I'm just using an imaginary number of 10. There's also a £3 charge for buying tickets. So after I've multiplied my 10 tickets by £24, I need to also add a £3. Add a £3. That's going to tell me how much my tickets cost. Now, if there was 5 people that called up to buy tickets, I would have 5 people times £24 plus my 3. Okay, so you can see if 100 people called up to buy tickets, I would have to do 100 multiplied by £24 to get the total cost of my tickets, and then add the £3. So let's have a look at the list below to see which one would match it. So I've got my sentence here with my imaginary number in, and below it I've just swapped my number for n. N stands for number of tickets. It can be any number of tickets. It will always be the number of tickets times by 24 and plus 3. Now if I look down here, I've got times by 3 and add 24. It's not that one. And here I've got times by 24 and add 3. I'm going to put a star by it because I want to double check. Plus 3 and times 24. Well, it's got the same numbers in it, so I'm going to put a star by it to check. And plus 24 times by 3. No, I definitely need to times 24. So let's just check these two. What is different between them? They've both got times 24 and add 3 in them in different orders. Does it matter what order it goes in? If I have a look back at my question, if there was 100 people, I've multiplied it by 24 and then added 3. In fact, what I'm going to do is I'm going to make this a bit easier by, let's say that we had 2 people. So 2 people, I times it by 24, and 2 times 24 is 48. And then I added 3, so it would be £51. Would it matter if I did it the other way round? If I had my 2 people and I added 3, I would have 5. And then if I did 5 times 24, I'm actually going to get 120. They are 2 very different amounts, aren't they? I need to, therefore, multiply by 24 first. It does matter which way round. And if you go back to our original statement, we start with the 24, then we add 3. So it can't be this bottom one in the 3rd place. It's got to be this one. But you can see how we've just checked for how reasonable our answer can be. In lots of those strategies we looked at earlier, it was check whether it makes sense, check the size. So always just check, especially with algebra, just replace a letter, give it an imaginary number and just test it out. And test it out a couple of times to see if it makes sense. Our final question today is also linked to the Year 6 curriculum. So let's start by reading the question. Adam is making booklets. Each booklet must have 34 sheets of paper. He has 2 packets of paper and there are 500 sheets of paper in each packet. How many complete booklets can Adam make from 2 packets of paper? We have lots of information here and we have quite a few things in bold. So it's already directing us to look at the important information. Okay, Adam is making booklets. That's probably not so important in our calculation. It's just important for the context of the problem. So each booklet must have 34 sheets of paper, each booklet. He has 2 packets of paper and there are 500 sheets of paper in each packet. And I'm going to highlight these 2 in a different colour because these 2 are linked. He has 2 packets of paper and down here we want to know how many booklets, complete booklets as well. Complete is going to be important. How many complete booklets can Adam make from 2 packets? So I'm going to go straight to my 2 packets. Well, my 2 packets of paper, there's 500 sheets of paper in each packet. So the first thing I'm going to do is to start. I know that I'm going to have to do lots of calculating. There's lots of steps in this. It's not usually just 1 or 2 steps in these complex problems, especially when there's 2 marks in the question. So let's just start to gather information. My 2 packets of paper, 500 sheets of paper in each packet. I know I'm going to have to do 500 times 2. So I know that this is going to be 1,000 sheets of paper. 2 packets of paper, 500 sheets of paper in each packet. I've got 1,000 sheets of paper. Okay, the next part. Each booklet must have 34 sheets of paper. Now, if you're not sure what to do here, you could start to draw diagrams. Okay, you might not finish the diagram, but sometimes just drawing the problem might help. I've seen lots of people do the wrong calculation for this problem. They've got the numbers, but they've divided things by the wrong number. They've multiplied things by the wrong number. They've subtracted when they should have been dividing. So I first of all figured out that I've got 1,000 sheets of paper, and I now know that each booklet must have 34. Now, if you think about it, if I was to draw a booklet, that needs 34 sheets. Draw another booklet, that needs 34 sheets. Draw another booklet, that needs 34 sheets. every time I make another booklet, I need to imagine you've got the 1,000 sheets of paper in front of you, and I'm going to subtract 34 to make that booklet. I'm going to subtract another 34 to make that booklet. Subtract another 34 to make that booklet. I'm going to keep taking 34 away. Now I don't want to do 1,000 take away 34. So I'm just going to write the answer in because I know that it's 966. Now I don't want to then take away another 34 and take away another 34. That's going to take me forever. But I know that repeated subtraction is the same as division. Just like repeating addition is the same as multiplication, taking away over and over again is the same as dividing. And actually, this is dividing, this is sharing, because I'm having to equally share. Each booklet has to have 34 sheets. So I'm going to divide my 1,000 sheets of paper by 34. So I'm simply going to do 1,000 divided by 34. Now, the next part of it is to do long division. So for long division, the best thing to do is to make a list of multiples. So I'm going to create a list of multiples down the side here. Okay, so I've made my list of multiples and now I can start to divide. So 34 is not going to go into 1. 34 is not going to go into 10. How many times will 34 go into 1,000? 100, sorry. If I go down my list, I can see it's only going to go in twice. I'm going to prove that by writing 34 times 2 is 68. And I now subtract that. 100 take away 68 is 32. So I'm going to bring my 0 down. And now how many times does 34 go into 320? And if I go down my list, I can see it only fits in 9 times. I need to prove that now by writing 9 times 32 underneath my 320 and subtracting that, and I'm going to have 14. So my answer, I could go on to write it as decimals, but I know that I can make 29 packets with 14 pieces of paper left over. Now, something else I've seen people do is to write the answer in as 29 remainder 14. But if I look back to my question, how many complete booklets can Adam make? Well, he can make 29 complete booklets. 29 booklets will have 34 pieces of paper in it, and there'll be 14 spare pieces of paper left. But the question wants to know how many complete booklets can be made. So our answer is this. It's 29 booklets. So always make sure that once you've completed your calculation, you don't just write in the answer your calculation came up with. Make sure you read the answer. You may have changed your remainder into a decimal or a fraction, but the question asks for complete booklets, so you must make sure that from your calculation you interpret your answer and you write in what the question is asking you for. If you would like more problem solving and reasoning style questions, please sign up for free at www.pocketprivatetutor.co.uk. You can also find us on Facebook and Instagram, where I'll be posting regular activities, games, problems and puzzles. Please check out the comments or the title description for links to some other word problems so you can put some of your skills into practice.